All right, so are you ready to tackle some, like, seriously big questions today? The kind that keep you up at night.
I think I'm ready.
You want to understand how the universe began,
By thinking.
time and energy, and how it all started.
That's the big one.
Well, the sources you sent me actually propose a pretty wild theory
Okay.
to try and explain all that, starting with something called an alien particle. Now, before you go picturing, like, spaceships and,
Little green men, right?
exactly, we're not talking about that kind of alien.
Okay.
This alien particle is more of a hypothetical thing,
I see.
maybe even from another universe entirely.
Literally.
Yeah. It's kind of like this cosmic seed.
The seed.
Yeah, that could have kick-started everything we know.
So like the beginning of the universe.
Sure, yeah.
Yeah, wow.
See, wild, right?
Yeah.
These sources are actually excerpts from a conversation with a large language model, which is already kind of cool.
Oh, wow.
But just a heads up,
Yeah.
we are going to be wading into some pretty speculative territory here. So think of it like a thought experiment,
All right.
a chance to, like, really stretch our imaginations,
Sure.
but based on some, like, real physics.
Gotcha. So how does this alien particle idea actually work?
Well, and that's what's so fascinating.
Yeah.
Is that this idea, it seems really out there,
Yeah.
but it has roots in, like, real quantum mechanics.
Oh, wow. So this
Yeah.
is like...
And remember, quantum mechanics is all about the weird and the counterintuitive.
Right, right.
So let's break this whole thing down.
Okay.
How could an alien particle from another universe even, like, interact with ours in the first place?
Yeah, good question.
Like, what would that even look like?
Right.
So imagine the quantum field as, like, a fabric.
A fabric.
Yeah, that permeates all of reality.
Okay, I'm picturing it.
Okay, and particles are like ripples in that fabric.
Okay.
But what if those ripples could extend, like, beyond our universe?
Beyond our universe.
Into other dimensions or other quantum realms?
Okay.
You following? So this alien particle is kind of like one of those ripples
Okay.
that crossed over from another, like, fabric of reality.
Another fabric.
Yeah,
Whoa.
exactly.
So other universes could have like their own sets of rules and particles and stuff.
Yeah, potentially.
That's wild.
And sources suggest that this interaction,
Yeah.
like this merging of ripples, could have been the spark that ignited the Big Bang.
Whoa. Okay, so we have this alien particle
Right.
triggering the Big Bang.
Yeah.
But I'm still a little confused about time.
Yeah.
You mentioned earlier about a timeless initial state of the universe.
Right.
What does that even mean?
Right.
Was there just nothing?
It's not really about nothingness.
Okay.
It's more about a state of perfect balance.
Perfect balance.
Yeah.
Mm.
Imagine a cosmic seesaw,
Okay.
perfectly level.
Okay. I'm with you.
No up, no down, no movement. It's
Okay.
that time as we understand it
Yeah.
wouldn't exist.
It's no time.
Yeah, there's energy,
Okay.
but it's latent, like pure potential.
Pure potential.
Yeah, it's like a tightly wound spring waiting to be released.
Mm.
So this alien particle upset the cosmic seesaw,
It did.
kickstarting time and the expansion of the universe.
Okay, but what tipped the scales?
Right, like how do you go from this perfect balance to everything we see?
Yeah.
Well, the sources suggest a fascinating link to electromagnetism.
Electromagnetism, like a light.
Yeah. Remember, even in a timeless state, quantum fields would still be, like, buzzing with activity.
Mm.
What if fluctuations in the electromagnetic field
Yeah.
were the key
The key to what?
to time?
Okay, wait. Are we saying that light created time?
It's a crazy idea, right?
Yeah.
But the sources propose that these electromagnetic fluctuations
Yeah.
created the first photons.
Oh, so the particles of light.
Exactly. And here's where it gets even wilder.
Even wilder.
The spin of those first photons.
Okay.
They're like intrinsic angular momentum.
Okay.
Could have been the first, like, tick of the cosmic clock.
So in this model, light isn't just like illuminating the universe. It's keeping time.
Yeah,
That's pretty radical.
it is. And it challenges us to rethink our understanding of both light and time.
Right.
But even if we go with this,
Yeah.
it still doesn't explain how this alien particle actually, like, left its mark on our universe.
Right. You can't exactly go digging around for it.
Well, about that.
Yeah.
The sources actually suggest that we might be able to find evidence of this whole scenario.
Really?
And not just evidence of the alien particle.
You know.
Maybe even glimpses into, like, previous universes.
Now that's what I call a deep dive.
It is, right?
Pushing the boundaries of like cosmology and physics.
Exactly.
Yeah.
And it all starts with understanding something called the cosmic microwave background.
Cosmic microwave background.
Yeah. You familiar with that?
I know it has something to do with the afterglow of the Big Bang,
Right.
like a baby picture of the universe.
Exactly.
Okay.
And the sources propose that the cosmic microwave background, or CMB for short,
The C
might hold some subtle clues about the alien particle and the cyclical nature of the universe.
Okay, so we're about to get into some seriously complex stuff.
I think so.
How about we make sure we're both on the same page?
I think that's a great idea.
Define some key terms,
Yeah.
and then unpack what the CMB business is all about.
Yeah, because it's a lot.
Yeah.
All right, let's do it.
Okay. So before we went on that little tangent, you were explaining the cosmic microwave background.
Right, the CMB.
CMA.
It's like this faint echo of the Big Bang that we can still, like, see today.
Yeah.
But how can something so ancient tell us about an alien particle or other universes?
Well,
It sounds like we're trying to read tea leaves here.
well, it is a little more scientific than that, but you're right. It is a subtle science.
Okay.
Think of the CMB as a tapestry
Okay.
woven from light and energy.
Okay.
Most of it looks pretty uniform,
Yeah.
but there are these tiny variations, almost like imperfections in the weave.
And those imperfections are what we're interested in.
Exactly. Those variations could hold clues about the very first moments of the universe.
Very first moments.
Yeah.
Okay.
What if, and here's where the alien particle comes in.
Okay.
What if those variations are actually imprints left by that particle as it interacted with our universe?
Oh, so we're talking about, like, looking for patterns in the CMB.
Right.
That wouldn't be there if the universe just, like, began in a perfectly uniform way.
Exactly.
Evidence that something from outside our universe was involved.
Precisely.
But what kind of patterns are we talking about?
Well, the sources point to a few things.
Okay.
One is the polarization of the CMB.
Polarization.
Light can be polarized, meaning its waves vibrate in a specific direction.
Okay.
By studying the polarization patterns in the CMB, we might find anomalies that point to the influence of the alien particle.
So we're looking for patterns that just don't fit with the standard Big Bang model.
Yeah.
Evidence that something else was involved.
Precisely, and there's another layer to this whole thing. The idea of a cyclical universe.
Cyclical universe.
What if our universe isn't a one-off event, but part of a chain of expansions and contractions?
Hold on, a cyclical universe.
Right.
So the Big Bang wasn't the beginning, just like a new chapter in an ongoing story.
Yeah, it's heavy stuff.
It is.
But think about it.
Okay.
If the universe expands and then contracts, could some information be carried over from one cycle to the next? It's like a cosmic echo.
A cosmic echo.
Or maybe even like a cosmic memory.
Okay, I'm trying to wrap my head around this.
It is a lot.
So let's say the universe goes through these cycles.
Yeah.
What happens at the end of a cycle?
Yeah.
And how does it start again?
Well, one possibility is that the universe collapses back in on itself.
Collapses back in on itself.
Sort of like the Big Bang in reverse.
Okay.
And then rebounds into another expansion.
And so what would that be like?
Some physicists call this the Big Bounce.
The Big Bounce?
Yeah.
And what about that information transfer you mentioned? How could information possibly survive like such a violent event?
That's the really mind-boggling part.
Right.
The sources suggest that even in a state of extreme compression, some quantum information might be preserved.
Preserved.
It's encoded in the very fabric of space-time.
So each news cycle wouldn't be like a completely blank slate.
Right.
It would inherit something from the previous universe.
That's the idea, and those inherited patterns might be reflected in the CMB.
Okay.
Imagine it like this.
Great.
You bake a cake, and even after you eat it, the pan still holds that faint scent of the cake.
Okay, I like that.
So the CMB is like the cosmic baking pan,
Uh-huh.
and those subtle variations are the leftover scent from the previous universe.
Okay.
It's a way to visualize it.
Yeah.
Now, combine that with the idea of the alien particle,
Okay.
and things get really interesting.
Okay. How so?
What if that particle isn't just some random visitor from another universe, but a vital part of the cyclical process?
Okay, now you've lost me.
Okay.
What do you mean by that?
What if the alien particle acts like a seed,
A seed.
carrying information from one cycle to the next,
Okay.
helping to shape the new universe?
I see.
Or maybe it's more like a catalyst,
A catalyst.
triggering the big bounce or whatever mechanism causes the transition between cycles.
So instead of just a random anomaly, the alien particle could be like a fundamental part of how the universe works,
Yeah.
ensuring that each cycle isn't completely random, but builds upon what came before.
That's one interpretation.
Okay.
And it has some pretty profound implications for our understanding of time energy and like the very nature of reality.
Yeah, that is pretty profound.
It is.
To explore those implications,
Mhm.
we need to go beyond just the CMB, though, right?
You're right.
We need to look at, like, the large-scale structure of the universe.
Yeah.
Galaxies, clusters, the cosmic web itself.
And to understand how that structure came to be, we need to delve into the concept of symmetry breaking.
Symmetry break.
Have you heard of that before?
I'm not sure I fully grasped what symmetry breaking is all about.
Oh,
It sounds like something out of a physics textbook.
It might sound complicated, but it's actually a pretty fundamental idea.
Okay.
Imagine a perfectly symmetrical object, like a sphere.
Okay, a sphere.
No matter how you rotate, it looks the same.
Yeah.
Now imagine you just like dent the sphere.
Okay.
You've broken the symmetry.
I get the visual,
Yeah.
but how does this apply to, like, the universe as a whole?
Well, the sources propose that the initial timeless state of the universe
Uh-huh.
was a state of perfect symmetry.
Okay.
Everything was in balance
Right.
with no distinctions or variations.
Okay, and then something broke that symmetry.
Yeah,
Leading to the Big Bang and the creation of, like, everything we see.
exactly. That something could have been the alien particle or some other quantum fluctuation.
Okay.
And here's the key.
Yeah.
Symmetry breaking isn't just a one-time event.
So you're saying it happens over and over again.
Right. As the universe evolves, it undergoes a series of symmetry-breaking events.
Series of symmetry breaking events.
For example, the formation of galaxies and stars
Yeah.
is a result of symmetry breaking.
Yeah.
Okay.
And the sources suggest that similar events might play a role in the cyclical process.
So each cycle of the universe involves a cascade of these symmetry-breaking events.
Right.
Each one adding complexity and structure.
It's like a cosmic dance.
A cosmic dance.
With symmetry breaking as the choreographer,
Okay.
shaping the universe from a simple homogeneous state
Mm-hmm.
into the intricate tapestry of stars, galaxies, and planets that we see today.
That's a beautiful way to put it.
It is pretty amazing.
But it also raises a question.
Yeah.
If the universe cycles,
Yeah.
and each cycle involves symmetry breaking, wouldn't that mean that the universe is constantly like becoming more complex?
That's a great question, and it leads us into some even deeper waters.
Deeper waters.
To understand what a cyclical universe might mean for complexity, we need to talk about entropy.
Entropy, isn't that like a measure of disorder?
You're on the right track.
Okay.
Entropy is a fundamental concept in thermodynamics.
Okay.
It's a measure of how dispersed energy is in a system.
Basically, the more entropy a system has, the less organized it is. Basically, the more entropy a system has, the less organized it is.
Right, okay, so we've been talking about entropy.
Yeah.
This idea that the universe kind of tends towards disorder.
Right.
But if the universe cycles, and each cycle builds upon the previous one, wouldn't that mean entropy is decreasing? It seems like that would violate, like, the laws of physics.
That's a really sharp observation.
Yeah.
And it's a question that physicists are still grappling with.
Okay.
The classic view of entropy suggests that in a closed system, disorder always increases over time.
Okay, so, like, think of a tidy room.
Yeah.
If you don't actively, like, put things back in order, it will naturally become messier.
Right, exactly. Like your desk after a long day, papers everywhere.
Exactly. But you're saying that a cyclical universe might, like, challenge that classic view.
It definitely raises some intriguing questions.
Okay.
If the universe cycles and each cycle inherits information from the previous one,
Uh-huh.
are we really dealing with a closed system? Or is there some way that information and order are being, like, injected into the system,
Injected.
counteracting the increase in entropy?
So maybe it's not a simple case of entropy always increasing.
Right.
There could be other factors at play, especially if we're dealing with a universe that, like, renews itself.
Precisely. And the sources we've been discussing suggest that symmetry breaking, the process we talked about earlier, might be a key part of this puzzle.
Okay, remind me, how does symmetry breaking tie into entropy and this whole cyclical universe idea?
So remember, symmetry breaking is about going from a state of high symmetry,
Like a perfectly smooth sphere.
exactly,
Right.
to a state of lower symmetry.
Like that sphere with a dent in it?
Right. In a way, each symmetry breaking event creates more distinctions,
Yeah.
more complexity, more order within the universe.
So even though entropy might be increasing within a single cycle, the process of symmetry breaking as the universe goes through multiple cycles
Yeah.
could be creating a kind of overall increase in complexity.
That's one way to think about it. It's like saying that while each individual wave on the ocean might break and dissipate,
Yeah.
the ocean as a whole is still capable of generating new waves, new patterns, new complexity.
I see what you're getting at.
Yeah.
It's a more nuanced view of entropy. where the overall complexity of the universe could be increasing,
Uh-huh.
even if entropy is increasing within individual cycles.
Exactly. And it's a concept that physicists are still actively researching and debating.
Okay.
But it points to the fact that a cyclical universe, if it does exist,
Yeah.
wouldn't simply be a repetitive loop. It could be a process of ongoing evolution and development.
That's pretty mind-blowing.
It is.
We started with this idea of an alien particle,
Right.
and now we're talking about the fundamental nature of time entropy and the evolution of the universe itself.
Yeah, it's a lot to take in.
It really is.
But it's a testament to how interconnected these big questions really are. And it highlights the importance of keeping an open mind, of being willing to explore ideas that challenge our conventional understanding of reality.
Okay, so we've gone on this incredible journey through some seriously complex concepts.
Yeah.
Alien particles, cyclical universes, symmetry-breaking entropy, and the nature of time itself.
All the big ones.
Where does this all leave us?
Yeah, where do we go from here?
What are the big takeaways?
I think the most important takeaway is that our understanding of the universe is constantly evolving.
Right.
We're constantly making new discoveries, developing new theories, and revising our understanding of how things work.
So even though we don't have all the answers right now, the very act of asking these big questions, of exploring these mind-boggling possibilities, is pushing us closer to a deeper understanding of the cosmos.
Absolutely. And who knows what incredible discoveries await us in the future?
Yeah.
Maybe we'll find definitive evidence of alien particles or confirm the existence of a cyclical universe. Or maybe we'll discover something even more unexpected and awe-inspiring.
Well, on that note, I think it's time to wrap up this deep dive.
Okay.
It's been a truly fascinating exploration of some of the most profound mysteries of the universe.
I agree.
And remember, the journey doesn't end here.
It doesn't.
Keep looking up at the stars, keep asking questions, and keep exploring the wonders of the cosmos. Who knows what amazing insights you might uncover.
Good advice.
Thanks for joining us on this incredible adventure. Until next time, keep those minds curious and keep diving deep.